Now that we've talked about classification error, we can explore the notion of overfitting in classification. But before we start, let's review what we talked about when we discussed overfitting in the regression course. Going back to the regression course, we had this running example where we're trying to predict the price of the house in the y-axis given some features of the house. In this case, in the x-axis is the square feet or size of the house. And we see on the left here a really nice smooth curve that helps us predict what's the price of a house given its square feet. However, if instead of using a second degree polynomial like we did on the left, we use a higher order polynomial, we might get a really crazy wiggly line that fits the training data extremely well, but doesn't generalize beyond the training data to data in the test set or in the truth in the real world. And so in this case, we say that the model F here has overfit the training data. Now in classification, we're going to have the same kinds of problems and we're going to have to try to address it. What happens when you learn a model which is too good on the training data, has a training error that's too low, but doesn't do well on the true error. Now let's review some of these overfitting plots which we discussed quite a lot in the regression course. So here in the x-axis, I'm showing the model complexity. The model on the left is a very simple constant model, while the model on the right is a crazily polynomial of very high degree. So if you look at the training error, when you use a constant model, it doesn't do really well on the training data, but if you use this crazy high degree polynomial, it might get zero training error. And somewhere in between, you get training error that is decreasing like this. So, and eventually goes to zero. So this is my training error. And the problem with training error goes to zero is if you look at the underlying model, it doesn't do well on other houses, so the true error is very high when you don't have a lot of data. Sorry, when your model is very simple, but it's also very high when your model is very complex. And the true error function has this kind of characteristic process goes down and it goes up. So this is the true error. So overfitting is going to happen when we pick something that's too good in the training data, so it's somewhere over here, but it doesn't do well with respect to true error. So in other words, you get some W hat over here that has very low training error but high true error, while there exists some other set of parameters, we can call them W star, which might not have done as well in the training data, but man, they did much better as a performance in the true error. And so we want to try to avoid picking this highly performant models in the training data that don't do well in the real world. So we want to shift from the right here to the left to avoid overfitting. Now this was for the regression setting. Next we're going to talk about it in the classification setting.